Hi, my name is Phil Singer. Thank you for watching my video. The reason I put this video together is several months ago, somebody asked me on LinkedIn some questions about getting Jersey2 working with authentication. And originally it started off as basic authentication, but as the dialogue evolved, I realized what they really needed was Jersey2 Security with JWT. So the purpose of this video is to discuss as a code review how the security will work in this Jersey2 Security JWT project. We'll also explain what JWT is and why I directed the user towards JWT. So with that, let me get going. What I'm going to do first is I'm going to discuss our first objective, which is to explain what JWT is. Now, I've stumbled on this website I would like to direct you to called jwt.io. They have a /introduction area, which goes into much better detail than I can possibly do justice for in this video. It explains what it is, and I can give you just a brief overview. Basically, JWT stands for the JSON Web Token. There are several different types of JWT. There's JWA, JWS, and a few others. I thought JWT was pretty decent. The specification for it can be found here on this IETF website. We'll go into much greater detail, but what I'd like to do is explain to you how it works. Now, before I go into the actual format, I'm going to show you what would normally happen in a HTTP transaction. If you were able to sniff the connection between a REST service and a client, you would see something like get space HTTP localhost 8080 books, okay? And then you would see the client also say, I accept application JSON, and my authorization is bearer, and then this big massive string at the end. The server would then respond with a 200, and here is your payload. So this part right here, all the way to the end of this massively long string, is in fact JWT. If this was basic authentication, instead of the word bearer, it would say basic, and it would have another crazy looking string there, and that crazy looking string would end with a equal. That would be a base 64 encoded username and password separated by a colon. The server would have to base 64 decode it and re-authenticate each request coming through. This has got way much more information in it and is arguably more secure. I say arguable because nothing is impervious to security. There are problems with this technique, but it's okay. So what actually is JWT? We just saw this big massive string here. Where did we see that string? Let's go back to this real quick. We see this big massive string here, but we see a period there, and we should see a period there. A JWT is broken up into three parts, separated by periods. The first part is called the header. The second part is called the payload. And the third part is called the signature. It is possible for you to push X509 certificates to mobile apps, have them sign the payload and send it back. Since you issued the certificate to them, you in theory can validate that. We're not going that way. what we're doing is we're using our own key, private key, public key, and we are signing those payloads with one single key. Now, there is a problem with that technique. It can be compromised. I'm going to discuss how to protect yourself against compromisation and what you can do to prevent it from happening. So let's keep talking about JWT. So what's in the header? Well, for starters, the header is base 64 encoded. And what it contains is a string, which is a JSON object literal. It has two mandatory parts, an ALG and a TYP. The ALG, by the way, this is all covered in RFC 7519. The ALG is the algorithm that was used in the signature. There is HIMAC SHA-A256 and a RSA version of it. I would strongly advise you to use the HIMAC SHA-256, which is HS256, and I believe the RSA one is RS256. Use the HS256. And as I mentioned to you earlier, there are different types of JWT. There's a JWA, a JWS, and a few others. We'll just stick with JWT. It's the best. Again, this entire JSON object, JavaScript object literal is a JSON. It is base 64 encoded. So I'll give you an example of what I'm talking about. Let's go back here to the Jersey thing. You see this first part here? I'm going to decode it so you can take a look at what it looks like. I'm going to go to this website here and I'm going to paste this in. I'm going to decode it. So there you go. Algorithm HS256 is embedded inside this. I defaulted my system to JWT. You don't have to put JWT in as the type. You can if you want. Doesn't matter. It's up to you since you're the one controlling it. So what's the second part here? Let's double click on that. It's huge. Can you see how big that is? Let's grab that guy. Let's decode that. Let's take a look at what that looks like. Well, it has some strange stuff in there. ISS, sub, AUD, EXP, IAT, and JTI. You want to know what all those are equal to? And what more options are there and which ones are required? You can hit up the IETF org RFC 7519 to find out what they really are. But I'll give you a hint. ISS is the issuer. That would be my website. SUB is the subject. That would be my username. Audience. Expiration time. Not before. JTI is the JWT ID. I use the JTI as my version number. I use my expiration time twice. Once as clear text in the payload response and once inside the JWT token. MBT or MBF is not before. You can issue a token preemptively, or you can say you want to issue it at a certain time. Okay. Audience is not very clear on what that specification is. I use it for my roles in this particular project. Okay. So using the JWT.io website, we can kind of look a little bit more into what they say it looks like. Again, the payload has some reserved claims, a subject, that's the user, an audience, an issue, an expiration, etc. I'm not going to go into private and public claims. This all has to do with third-party apps, etc. It's way beyond the scope of what I want to talk about. Again, that payload, as I just showed you, is base 64 encoded as well. Now, they've done a really good job of showing you a sample of how this whole thing works. Here is an actual string, and they've gone and done a beautiful job of color coding it and breaking out each section to show you exactly what it would look like. If you start tootling with this, you'll break this whole thing. It will say signature won't work. So if you're actually going to try to goof around with this, you're going to have to learn how to do SHA 256 signatures on this so that you can plug it in here and actually do a validation check on it. Okay. So that's pretty much what happens here. This is just a signature and a clear text payload that's been base 64 encoded. Now there's two things that should worry anybody who understands base 64 and authentication, etc., and security. It's clear text. It's just base 64 encoded. Anybody can crack it open. So that means you're not going to want to put stuff inside this payload that will compromise the user. For example, putting the user's password in would be a horrible idea. Putting the user's tax ID in would be a horrible idea. Putting in their phone number would be questionable. I would say even a bad choice. Putting in their full name with their address and where they live would be an incredibly bad choice. There are some good things about it being base 64 encoded. If you have a SPA, a single page app, and your menu structure changes based on the security roles, it would be nice to be able to get all the way the screen should be rendered with one request. That can be accomplished by putting the user's roles into this particular field. A normal SPA who doesn't have access to this would have to go back to the server and say, hey, I've got this user. How do I construct the screen so that they can and cannot see particular items on the screen? That's unnecessary because you've got it, if you've encoded it in here, the roles. Now, you might also say, well, this really isn't secure because a man in the middle can sniff this token out and use it. And that's why we can put things in like JTI. We have JT. I don't have my glasses on, but I think it's JTI. And if you look that up, it is the version number. Yeah, it is the JTI claim. It provides a unique identifier for the JTI. I use this as a version number. So what that allows me to do is if I release a new version of the app, I can bump up the JTI. I can go into the database and I could say, hey, all my users now have a JTI of N+1. What that would do is it would invalidate all the tokens that are out and force the user to relog in. Okay? The other thing it can do is it has an expiration time in here with the EXP. That means that token is only good for so long. So if a man in the middle does get the token, it will only work for so long. Now, some people like to use refresh tokens, a subsequent token, so that they can go get a new token without going through the authentication process. I'm not going to debate that, but that's one way of doing that. Mine does not have an expiration token. But what I have done is I have added an expiration time. I added in both the payload. When you get an authenticated token, you get an expires in as a clear text, and it's also inside the payload as well. Hold on, I got to pause this video. Apologize. So I have the token expiration time inside here, and I have always the expiration time as part of the content of when the user authenticates. I do this for two reasons. The first reason is it's really easy for a mobile app to pull this out and store it. But the thing that I've noticed is that some people choose not to do that, and they'll hold on to the token, and they will have maybe rebooted the app and lost this information. Having it available as an expires inside here allows them to have a backdoor into finding out what this time originally was since the app shut down. Okay? Okay, now I'm going to explain how the app works and how this particular process that you're looking here, or sequence of steps, is working. What we're showing here on the README part of the GitHub project is basic steps for authentication and how it all works together. So basically, we're doing a post on authentication. I'm telling it, hey, this is a URL encoded form with the Iron Man as the username and password as password. Of course, this should not be over HTTP. It should be over HTTPS. The server responds with a status code of 200. Your content type is application JSON. Here is your token that expires. And then the user can then go on to go get some books and then passes a bearer and then that JWT token. So let's walk through the application here. So I wrote this project to use Tomcat as its container, not Grizzly. Grizzly is the container that comes with Jersey. The person who asked me the original question was they wanted it to run in Tomcat. I don't remember the version, but the Tomcat that they gave me was a 2.5 server spec, so 7 can work with that just fine. That means that there is a web XML that launches the application by calling out comp sample application. When you execute it this way, it has to have a 0arg or a init params. My 0arg actually then calls out my non-0arg. I instantiate a book DAO, inject it in through composition, as well as a user DAO and a generated Mac provider key. Now, I'm not going to go into the details, but you're going to want to actually have a different type of way of injecting the key. Every time this server is fired up, it generates a completely new key, and this is not something you want to put in production. Especially if you're going to cluster it. You don't want to have every item in the cluster to have its own unique key, so you'll have to figure out how to do a key that can be shared across or deployed to the whole thing. Now, another thing, too, you're not going to want to do in production, you're not going to inject a whole bunch of books that are already done, and you're not going to want to inject Iron Man and his password into the user database from the beginning. Since I'm using this for testing purpose and illustration, it was easy just to do it that way. So in the non-0arg, here you can see we're injecting stuff, and we've got setters we're setting. And now I want to actually start setting up how things are working. I've got a logging filter turned on. There's ways you can use validators on the actual data transfer objects so that you can use, here's a book. You can, I don't think I have any validation turned on. Oh yeah, actually I do, but here. This validation is the normal validation. You can control how you want to have validation injected into the whole thing via this. There's Hibernate and a few others as well. I'm using just the default. It works fine for me. The roles allowed dynamic feature will look at the annotation on the actual service that has roles allowed. That works in context with the security context, which I'll be showing you how to set here in a second. So I created the JWT filter class. There are two ways of doing this. There is a filter or an interceptor. They both have different characteristics. The filter seemed to be the right thing to do. It's a intercepts every request and response type thing. You can mitigate how you want it ordered in the sequence of the workflow. I only have one. I didn't need to do it. This JWT security filter actually reads the token from the header, tests to see if it's valid, tests to see if the version is valid, tests to see if the user exists, tests to see if the rules exist, etc. And we'll pass it on or not. So we'll step through this. So the first thing we're going to do here is we're going to look at what's injected. So we're using the HK2 injection. This is similar to Spring's injection in some ways. I would have had to have registered this DAO and this key with the actual application for it to be available. I did that down here when I created a abstract binder, and I said get the DAO from myself. If you see a book DAO class wanting to be injected in the context, the same thing for the user DAO and the user DAO class and the key. Before I go too further back to the security, I'd like to also point out I'm scanning com.sample package for annotated resources and assets that tells the Jersey2 to scan this directory for things. I also prefer the Jackson JSON converter over the Moxie. It has some really good features that blow Moxie out of the door, and I'll show you those in a second as well. You can Google these additional properties you can send to Jersey2 to change the behavior of the app. I'm not going to go into that. So back to the actual security filter. So having registered those DAOs and keys with the contacts provider, I can actually scan and see that I need to bring those in. Also, I inject the URI. I'll go into that in a second. Where do I start? Okay, so let's just go right into the implementation of the filter. You need to inject the request context. That's going to have the method, what's being asked for, security, and a variety of other things. So the first thing I want to do is get the method off of the request. Methods are put, get, options, post, and too many for me to list in my given state. And the path is where they actually trying to go in the system. I'm going to keep it simple by using a lowercase on everything so that my tests are simple. Now, in order for you to authenticate or look at a application waddle, it didn't make sense for me that you had to be authenticated with a JWT token before. So if you're trying to get the waddle or you're trying to actually authenticate, I'm just setting the security context authorizer to anonymous. Now, what the authorizer does is it builds up a security context so that it can be injected in the appropriate places. That means the principal had to be overridden or implemented. The in-user roles is secure and authenticated schema. Since that's coming in as anonymous, it looks like anonymous to everything in the back end. So if there's no principal set, I'm basically defaulting it to anonymous. And then I return, which simply exits. So if you're trying to authenticate, you don't have a security context yet. You're passing your username and password. You're asking for a token. And if you're trying to get the application waddle, there's no need for you to pass anything as well. On the other hand, everything else is actually authenticated. So anything in this system, even if it's anonymous, requires something to authenticate with a security context on, okay? So the first thing I want to do is get the authorization header. If you remember in the GitHub project, this is the actual header that will carry the JWT token. It's then separated with bearer, not basic, because that would be basic auth. Bearer means non-basic. And then it has the JWT string. So coming back here, we get the authorization header, which is that big long thing that will say bearer space and then the JWT. If there's no header available, I throw an unauthorized exception and we're out of there. Well, it's not an exception. It's a web application exception of unauthorized. So that will be like a 401. What I want to do is extract the JWT token from the authorization header. So I've written this little piece of code that will take the actual header and rip out the word bearer as a regular expression and space. and pack anything in there that's spaced with blank just to be on the safe side. So now I have the token. I can ask my token utility, is this thing even signed with a signature correctly? So all this does is it gets the token and the signing key, and it says, was that signed? Is this a valid signature? Did somebody alter the payload? So if somebody alters the payload, this will return false. But that's all it will do. So I need to get the name, the roles, and the version out of there, and I need to validate every one of those. Oh yeah, it also checks date, pardon me. That expires as EXP is actually valid, a required field as well. So if I'm not mistaken, the is valid will check for that as well. So if there was no name, or the roles were empty, or there's a version of -1, token is invalid, and I throw unauthorized. If the user DAO didn't exist, we throw a user not found error, and we exit out of here with unauthorized. If the user is null, oh, I'm sorry, if the user is not null, then we get the version and the roles, and we convert all that to an array so that when we set the security context authorizer, we've got it all available as roles, which then can be read by the roles allowed check. Once that's all done, everything's available as injected components in the actual resources. So let me just show you where we actually would use that. On the actual user get user resource, where you get by an ID, there's a need for the admin to be able to get everybody's user ID. But we don't want everybody to get everybody else's user ID. We just want the admin to get everybody's ID, and we want the actual user to be able to get their own user information. So how do we go about doing that? Well, the security context is injected in, and what that allows me to do is then say, hey, this is protected by a user role and admin role. You need to have at least one of those. And what we're doing is looking at the security context to say, hey, if they have the admin role, they can go ahead and get anything they want. If they are not the admin security in the admin role, then what we're going to do is we're going to go ahead and get that user from the database. If we found it, actually this has probably got some bugs in it, because if the user is not found, I'm not sure what will happen. But I look at the username, and I look at the security context, get principal username. If they're equal, that means that the user is looking at his own user profile, and I return it. Okay? If they're not equal, I throw this not allowed exception, which translates to a 401, I believe. I'm not sure exactly. So that's how I use it at a microscopic level. Here's another example of where we're just simply getting the roles, and I'm saying, hey, look, only the admin can get all the users. Okay? So if I was a user trying to get the roles, it wouldn't work. I think that pretty much covers what I wanted to show about the security context and how the JWT falls into this. These two resources are pretty simple to understand. You feel free to look at it. The authentication resource is the one that's actually responsible for generating the JWT token, and then sending the user to the I'll go over this as well. What the heck? So there's no security on this resource because the JWT security filter let you come through here. What we're doing is you're giving us a username and password. I'm getting an expiration date of 15 days from now. I'm authenticating your information and getting a user object. And I think this throws a not found exception or something if there's some sort of a failure. I'm using my token utility class to generate a token based off of that information. I'm setting the authentication expiry. And this also is responsible for signing it. And I respond. Back on our web page, that would have been this response right here. And the reason I know that is if I go to a token object, this data transfer object has a auth token and expires in. By the way, this is one of the nice features of Jackson. I can say how I want the date formatted and in what time zone. I advise you to use UTC, not a local time zone. That will be much helpful for you. You can trust me on this one. Okay, only reason there's a main is if you wanted to use Grizzly. If you're going to be launching it from Tomcat or a web container, this is the way you'd want to do it because, or with the application, is because we call it out in the web XML. That concludes my demonstration and walkthrough of JWT. If you have any questions, please feel free to get a hold of me. I'm Phil Singer, Philip A. Singer. I'm located on LinkedIn at linkedin.com/in/Philip Singer. I am a lead software engineer. Please feel free to reach out to me if you have any more questions. Thank you.